Hello everyone, welcome to another episode from Chedexcel. So today we are going to talk about how we can do the enthalpy change calculation using the combustion enthalpy data. Now the last class we discussed how we can do the enthalpy change calculation using the formation enthalpy data. Today we are going to do how we can use the combustion enthalpy data to talk about or to find out the enthalpy change of a chemical reaction. So we'll see what is the combustion enthalpy data. Now what is the combustion enthalpy first? Right. Now the symbol for the combustion enthalpy is delta CH or delta HC. This is the symbol for the combustion enthalpy. Now the combustion enthalpy is defined as, this is the enthalpy change when 1 mole of substance is burnt in excess oxygen to give its products, combustion products at standard conditions. So if you have alkane or alkene, alcohol, carboxylic acid, aldehyde, ketones which contains carbon, hydrogen and oxygen, always the combustion product is carbon dioxide and water. If you have sulfur, then the combustion product would be sulfur trioxide, nitrogen dioxide, sulfur dioxide also can be when it is sulfur, it depends. Anyway, for most of the time, what you will be given is the one which contains carbon and hydrogen and oxygen. So the combustion products would be carbon dioxide and water. For example, combustion enthalpy of propane, C3H8. This is the reaction between oxygen to produce carbon dioxide and H2. This is a still liquid, this is a gas, this is a gas, and this is a gas. 3 carbon, so 3 here, 8 hydrogen, so 4 here, 3 into 2, 6 plus 4, 10, so 5 here. So this is the combustion enthalpy reaction of propane. Another one, let's say ethanol, C2H5OH, which is a liquid, oxygen gives you carbon dioxide and H2. This is also a liquid, this is a gas, this is a gas. How to balance? 2 carbon, so 2 here, 6 hydrogen, so total 3 here. 3, 2 into 2, 4 plus 3 is 7, which means 1 is here, so 3 here. So this is the combustion enthalpy. Now always the combustion enthalpy is an exothermic reaction. So it gives out energy, the negative values will be there. There are some cases where you can use the combustion enthalpy data, but instead of that they might give the formation enthalpy data. The case is this, let's say you consider the combustion of carbon. Combustion of carbon is C plus O2 CO. But one can say this is the combustion enthalpy of carbon, and another one can say no, this is the formation enthalpy of carbon dioxide. Why? C plus O2 CO2. This is the same reaction that we can write both combustion of carbon as well as the formation of carbon dioxide. So in many cases, sometimes you'll be given the combustion enthalpy data instead of formation enthalpy data. You should know that if you require the formation enthalpy data of CO2 and if you are given the combustion enthalpy data of carbon, that's the same thing. This can happen the other way around as well. Let's say combustion enthalpy of hydrogen is same as the formation enthalpy of H2. Combustion enthalpy of hydrogen is same as formation enthalpy of H2. Why is that? Combustion enthalpy and formation enthalpy the same. For hydrogen is the same as the formation enthalpy of H2O. So there are many cases like that as well. But generally, the combustion enthalpy, you have 1 mole is burnt with oxygen to produce carbon dioxide and water. That's the most common way that you get. So we'll see how we can use this data to find the enthalpy change of a chemical reaction. Now today in this one I'm not going to talk about how we can do the practical stuff like this. You have this spirit burn is there, measuring the heat. We are not going to do this because I'm going to do it separately when you discuss how we can use the what is the practical approach of the enthalpy reactions. But here we are going to do 2 reactions. I'm going to do 2 examples how we can use the combustion enthalpy data to calculate the enthalpy change of a chemical reaction. Now, to calculate the combustion enthalpy enthalpy change using the combustion enthalpy data, again we can do 2 methods. We can use a Hess cycle or we can use the formula. So we'll see how we are going to construct the Hess cycle. So I explained on the board how we are going to construct the Hess cycle. So this is not that hard. The first thing is the stepwise we have to write the balance reaction. Right? You write the balance chemical reaction. You will be given this one most of the time. That's the first step. Second step is you have to write the combustion products at the bottom. So what we are going to do is how to construct the enthalpy cycle, right? We are going to discuss how we are going to see the enthalpy cycle. Enthalpy cycle means something like these things we normally do. We are going to discuss how we are going to do such an enthalpy cycle if a combustion enthalpy data is given. So first you will write the balanced chemical reaction. Second one is write the combustion product at the bottom. That's the second step. Write the combustion product at the bottom and balance it. That's also balance it. Third step is arrows from top to bottom. And then fourth step, final step is write oxygen in both sides and apply Hess's law. So this is the normal steps. So we'll see how we are going to find, how we are going to do the enthalpy change using the given enthalpy data. So the first example is this. This is how we construct the enthalpy cycle. It's a basic idea you should have. If you want, you can just pause the video and get the idea. And we'll continue how we are going to construct his cycle using these steps. Right? So the first example I'm going to do is this one. Right? There's enthalpy cycle. They are asking to find out this reaction. Enthalpy change to find C3H6 plus hydrogen to produce C3H8. So they are asking the enthalpy change of this reaction. The data you are given is combustion enthalpy of C3H6 is given, which is minus 2219. Combustion enthalpy change of C3H8. C3H6, this is C3H8, C3H6 is minus 2058. All of them are kilojoule per mole. The combustion enthalpy of, here the formation enthalpy of H2O is minus 286. Kilojoule per mole. Right, now as I told you here, we will be given the formation enthalpy data of H2O, but formation enthalpy data of H2O means combustion enthalpy of hydrogen. So we need them. So we'll see how we're going to do this as I told you. So if you are given a question like this is your question, so you can take it down. Then we'll see how we are going to construct a cycle. Right. The first thing is you have to write the balanced reaction on top. So C3H6 plus H2 gives you C3H8. Then combustion products at the bottom. You will be getting carbon dioxide and water, nothing else. It's better if you can write as physical state. Then you have to balance it as well. 3 carbon, so you put 3 here. 6 plus 2, 8 hydrogen, so you put 4 here. That's it. So carbon and hydrogen is balanced, oxygen is not. Arrows from top to bottom. This is one arrow, this is the other arrow. And then you have to put the oxygen for both sides. How many oxygens are there? 3 into 2, 6. 6 plus 4, 10. That means total 10 oxygen. But we write it as O2. So you can write 5 O2. If you want, you can write it like this as well. That 5 O2 and 5 O2. Doesn't matter. You can like that. Or if you want, you can write them on the arrowheads like 5 O2, 5 O2. Both ways, doesn't matter. Fine. So I just keep it like this. And then delta RH. This is what we have to find. So we have to apply the Hess's law. So what is the Hess's law then? These two is equal to this one because arrows are going like that. So delta RH plus combustion enthalpy of C3H8 is equal, these two equal to this one. Combustion enthalpy of C3H6 plus combustion enthalpy of hydrogen. Right. So then we have to just apply them. So this is what we went first, so I put X for that. C3H8, I gave the value. C3H8 is minus 2219 equal combustion enthalpy C3H6 is minus 2058 plus combustion enthalpy of hydrogen is the formation enthalpy of water, which is minus 286. Then only thing you have to find is this. So X equals, when you do calculation, you will be getting it as minus 286 kilojoule per mole. It's a very easy one. And if you have to do it in a paper, construct everything by yourself, this will give you somewhere around 4 to 5 marks. Very easily you can get it. Right. So that's how we do, that's how we construct the Hess cycle. Now by looking at this Hess cycle, we can derive a formula, right? So what is the formula? Then the formula would be, you can see delta RH, the chemical reaction is equal. Now this one can be found by subtracting these two, subtracting this value from these two. C3H6 and H2 means the reactants. Formula is then combustion summation enthalpy of combustion, summation enthalpy of combustion of products, reactants minus summation combustion enthalpy of products. So this would be our formula to do the calculation. R is reactants minus products. So we can use another way, or another chemical reaction to do this. Let's say you have 2 moles here, you have to multiply it by 2, right? So we'll do another example and see. We'll do another example now. Right. So something similar. We are going to do it again. So there's the entire thing here. So C8H18, this is a cracking reaction to produce C3H6 2 times plus C2H6. Right. So this is the cracking reaction. The values are given, right? So I just give the value like this. C8H18 is minus 5470. This one is minus 2058, and C2H6 is minus. Okay, this is what we have to find, x, and this value is given as plus 206. So let's say how we can find the enthalpy change of this. So those the values I am given. These are the combustion enthalpy data, right? So again, what you have to do is, so if you want, you can get this question, copy down this. So we'll see how to find this one. So again, write the balance reaction on top. C8H18 gives you C3H6 2 times plus C2H6. Combustion products at the bottom, carbon dioxide and H2. Balance it, 8 carbon, 18 hydrogen, so 9. Then hide arrows from top to bottom. Then oxygen, 18 into 2, 16, 16 plus 9 is 25. So you have to have 25 over 2 O2, because O2 is there. You need only 25 oxygen. So 12.5 is enough. This side also 25 over 2 O2, right? So once you get this one, this delta RH, right? Once you get this one, you can just use the formula as well. It doesn't matter. No one knows whether you apply the Hess law and get the answer or using the formula. If you ask to construct the Hess cycle, construct the Hess cycle and then just apply the Hess law. So according to the Hess law, the formula, I'm going to find the formula. What is the formula now? Formula is enthalpy change of the reaction is equal reactants minus products. Summation of reactants minus products. Remember, when it comes to the formation enthalpy, it is products minus reactants. Now this one is summation of the reactants minus combustion enthalpy of products. So reactants is C8H18, which is minus 5470, is equal summation of the enthalpy change of the reaction delta RH, which is plus 206, that is equal the summation of reactants, in this case only one, which is minus 5470 plus reactants minus products, reactants minus products 2 into C3H6, which is 200 minus 2058 plus this one, that is what we are going to find x. Right, that is what we want. I just put it as x. So after this, you can just use the formula as well, especially for the MCQs. So when you subtract this, you can get the x. The x will come as minus 1560 kilojoule per mole. Right, so that's how we do the enthalpy change of calculations using the combustion enthalpy data. So this is the same thing for every other reactions. The same method you have to follow. Only thing is you have to remember how we can construct the Hess cycle. It's different from the combustion enthalpy data to the formation enthalpy data. Then we have one more thing to do, that is how we can do the enthalpy changes if the atomization or the bond enthalpy data is given. We'll do in another video. So this is how we do the calculations using the combustion enthalpy data. So get it and try to have it, use it to have your exams. Thanks for watching.